Hello class, today we're doing lesson number 5, multiplying fractions. Now, we have Mr. Jones, and Mr. Jones says here that the only fish that Mr. Jones caught on his fishing trip wasn't big enough to impress anyone, so he decided to stretch the truth by taking a photograph of it and having the picture enlarged. He began having the picture the actual size of the fish, and it was enlarged 1.5 times. But this didn't suit him, so he had it enlarged 1.5 times again. And how many times the size of the actual fish was the second enlargement? So the answer can be seen in the figures at the top of the next page. Okay, so we had the length, the original length. Okay, and I need to get my white marker and make it right. Okay, so we have the original length, which was x. Let's just call that x, right? And so we enhanced it, or we enlarged it when we multiplied by 1.5, and we can express 1.5, right, as 3/2. So we multiplied x by 3/2. Okay, but what did we do? We took that and we multiplied that by another 3/2. So we have 3/2 times 3/2 times x. Okay, so what do we end up with? Well, we know that we can simply multiply numerators and denominators here, and we end up with 9, 3 times 3, and 2 times 2 is 4. So we end up with 9/4 x. Now, from this example, we see that 3/2 times 3/2 is equal to 9/4. Now, notice that we could have gotten this result without this diagram by simply multiplying 3 by 3 to get 9 and 2 by 2 to get 4. What if fractions being multiplied have different denominators? Well, the next diagram shows that 2/3 times 4/5, which is 2 times 4 over 3 times 5, is equal to 8/15. Even though they're fractions in this multiplication problems have different denominators, the same method works. Okay, so you can take a look at this method here, and you can see where you have 4/5, 5th, 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 and then another 5th, right? And then you have 3rd, 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 and you have the 2/3. So we have 2/3 and 4/5 are equal to 8/15. All right. You're going to find that it's much simpler to multiply fractions than it is to add them, because you do not need a common denominator. Okay, because of this, it is usually easier to multiply two fractions than it is to add them. Now compare the two below. We have a over b plus c over d, and then we have to go with ad over bd plus bc over bd, and that's equal to ad plus bc over bd. Okay, quite a bit of work there. But when we multiply the same two, a over b times c over d, we simply say a times c over b times d. End of story. So you can see it's much, much easier to multiply than it is to add. So I guess that's a little bit of fresh air. Your homework's going to be a little bit easier. Well, not so easy. Well, it is going to be easier, but let me tell you that part of this is to show you that the factors that are hidden in there are all in, and this is where I've been leading to the terms factors versus terms. When we're dealing with addition, you're dealing with terms that are being added. So if we look again at the addition, we see that a over b plus c over d created a lot of complexity here in these terms. You don't have the same opportunity that you would have over here when we multiply them. And you're going to see how that will help you, but it does create a little bit of complexity that you don't necessarily just want to multiply everything together. And we're going to see that over here. We're going to actually factor out some numbers, because what it allows you to do is to simplify your expressions. Now, although the product of two fractions can be expressed as a fraction by multiplying numerators and multiplying denominators, it is usually desirable to express the result in lowest terms. So that's why I said, not so easy. Many times the easiest way to accomplish this is to merely indicate the multiplications at first and then remove common factors in the numerator and denominator of the product by dividing both numerator and denominator by. In other words, we just cancel out. So look at this example. We have 33. I'm going to clear this up because we're going to do a couple of these. And what we're trying to show you here is factoring. Factoring, factoring, factoring. There's really no easier way to express it than thinking of multiplication and division. And when we have numbers that are being divided that are the same, well, we can simply cancel them out. So that's what we're trying to do. Let's take a look at 36 over 77. And then we have 7 over 24. So what they did was they factored. I mean, we can simply multiply these out, okay? That's what they're saying. Let's just go ahead and put them all on the same line, and we could get our calculators out and have a real good time, right? But the problem is it's going to be very hard to simplify it later, okay? Sometimes it's best to take the terms that we currently have, and why don't we try factoring? Now, I see already that 7 and 77, they have common factors, and I see that 36 and 24 have common factors. In my head, I'm already seeing 7 as a factor here, and I'm seeing 12, because this is 2 times 12 and this is 3 times 12. So why don't we go ahead and do that? Why don't we go ahead and write this as 3 times 12 times 7, right? We can do that because it's 36 times 7. Well, that's 3 times 12 times 7. And then underneath, we can express 77 as 7 times 11. Okay? Now, I'm going to switch them because they want to switch them around only so we can put the common factors kind of underneath them. They do that. You don't have to do it. Maybe I wouldn't necessarily recommend it while you're learning this, but just remember to keep all of your factors there. Don't lose them. But they put 7 times 11 over here. Okay, so that's 1, and that's being multiplied over here by 2 times 12. Okay, so we have all of our factors. We have 24. That's 2 times 12 times 7 times 11. Now we see the opportunity to cancel these out, right? So those are gone. So we're left with simply 3 over 2 times 11. There are no common factors there, so we know that this is simply 3 over 22. Okay, so now you might say, well, why do we do that with numbers? Well, we're doing it with numbers, but we're going to end up really doing this more with algebraic fractions and algebraic expressions that have variables. And if you push everything together and create some very complex polynomials, the x squares plus 2x's plus, a number, or x cubed, 3x cubed. When you put them all together, it's going to be harder for you to pull them back apart. So sometimes we don't just do the math. We sit there and we try to find, wait a minute, there's an opportunity. So when you have things expressed as factors in their lowest form, as we did here, okay, we have this, and we rewrote it as this. Now we can see, oh, what a wonderful opportunity. So we take this really big, somewhat ugly problem, and we reduced it to 3 over 22. And you can do the same with some of the, again, biggest, ugliest, loudest, noisiest expressions that have multiple factors, or if you just take those polynomials and pull them apart, things that you learned in previous chapters, in like chapter 9, if you can do that, you'll be able to eliminate the noise. So let's look at our next example. We're multiplying x over 5 and 10 over x plus 1. So we have x over 5 times 10 over x plus 1. Now, here, there's really not a whole lot going on, but you better be careful. You got to make sure that you do have an opportunity to factor out. And if we did write this out and we expressed it by simply multiplying 10 times x, we didn't really do anything crazy here. We just put them together. Over here, if we just went and jumped in and start multiplying 5 times x and 5 times 1 and put 5x plus 5, that would cause us to have to go back and undo that. So we'll put this simply as 5 times x plus 1. Now we see the opportunity here of expressing this as 5 times 2 times x, right? And we have 5 times x plus 1. Okay. Now note, again, this is a factor. 5 is a factor and x plus 1 is a factor. You might say, well, I got x plus 1. That breaks the rules. No, this is a factor all to itself. Now, I couldn't just go in here and say, oh, I've got an x and an x. That would be wrong because x is not a factor. X plus 1 is a factor because it's all being multiplied by 5. X is simply being added to 1. You can't do that here, okay? But we do have the 5 and the 5, and that gives us simply 2x over x plus 1. And again, don't be tempted to think, oh, I've got a factor, I have an x here and an x here, let's get rid of it, and just say 2 over 1. Again, you would be breaking all the rules of math, and you would have the wrong answer, okay? So, let's look at example number 3 now. We have, let's clear this board again, and let's see, what do we get? Let's see, add these up here. They're going to have to do 2 different, otherwise I'd end up removing the title. So we have here. So what do we have? Get my pen back. We have x minus 2y over 2y. Okay, ooh. That was ugly. Now x, I don't know what's happening to me. X minus 2y over 2y. Again, don't be tempted to think, oh, that's easy. I could just eliminate these two. No, 2y is not a factor. It's a term. You cannot. You can only cross out, cancel out factors. Okay? And we also have 3x over 3x minus 6y. And again, yeah, you know what I'm going to say, right? Yeah, don't think of eliminating these things, okay? That's not how it works, okay? Now, what we do have are terms, and I'm going to start putting this around. That's why you got to start looking at things as terms. You can put parentheses around them, so it means it's together. You can't separate these two. You couldn't eliminate that because these are together. Same thing over here. They're together. You can't just eliminate these. And you know, it wouldn't even hurt to just do it looking at it this way if you want. You know, or you could even look at it this way because these are all being multiplied. Okay. So yeah, I made a little mess here, but you can do that, okay? Now we're not going to do that. Let's not get carried away with our parentheses. I generally like to see parentheses around binomials and polynomials when they're in these complex fractional environments because it lets you see them for what they truly are. By removing the parentheses, you might look at that 3x as being a factor rather than a term. So let's go ahead and write out the expression and put them all together, and we would have this would be equal to x minus 2y. I'm sorry, ran out the end of my writing board here. So x minus 2y as a factor and 3x, okay, as a factor. Now they've already done that, but again, we're going to see that 3 and x are factors to themselves, right? Let's just follow their their path. Now we have 3x minus 6y. Now, when I see anything within parentheses, a binomial, any polynomial, and I see common factors here, I say I can factor out. Okay, I'm already seeing that there's going to be an opportunity here simply because I know I can factor out this 3. And I'm going to end up with this term down here. But I got to factor it out first. So what do I end up with? Well, let's just go ahead and put things in a better order, let's say. So we're going to take the 3, x. Now they do separate these, and there's a reason, because you're going to see an opportunity. But we're going to leave this x minus 2y. And then we're going to take the 2y, right? And we're going to see that we can factor out the 3 here. So we're going to just put this around here. Again, these are all different factors where you put these parentheses, but I'm going to put the 3 here because I am going to take that 3 out of here. I'm going to factor, which means 3 times x minus 3 times negative 2y, or excuse me, minus 2y. Because if I factored out a 3, I would factor out a 3 here, so that's my 3 times x minus 2y. So this is equivalent to this. Now you can see why we did that, because we can take these and eliminate. In fact, we have an opportunity to eliminate the 3 as well. Okay? Which leaves us with simply these 3 factors, x and 2 and y, or x over 2y. So, again, I want to just go back and say all of this great and wonderful noise that we have, I call it noise because it's just noisy, you know, and it's just so much, and more than maybe our heads can comprehend. It's just very noisy. This all turned into something so simple as x over 2y. You could actually think of what x over 2y is. It's for every factor, or every number that is x, you multiply y times 2 and divide it into x, rather than all of this other stuff. And again, if you care to conceptualize and really see what the value of x over 2y is, you can. Those of you who truly love math and love numbers, you can really feel much more comfortable with x over 2y and really understand more what it is. So, alright, so although the main purpose of this lesson has been to learn how to multiply fractions written as quotients, it is important to realize that the arithmetical fractions can also be multiplied by changing them to decimal form and multiplying these in their decimal form. So we've already done that. We've seen it. This is an example: 3 over 2 times 3 over 2. Well, that would be 9/4. Well, if we did that as decimal, 3 over 2 is 1/2, and 1/2 times 1.5, not 1/2. 1.5 times 1.5, or 1.5 times 1.5, is equal to 2.25. And you'll know that 2.25 is equal to 9/4. Why? Because you really have 8/4 plus 1/4. And 8/4 is 2. And 1/4 is 0.25, which is 2.25. So, and of course you can do that on your calculator. So that is the end of lesson number 5.